Well, you see, there is a kind of quiet shiver that runs through the mind when we imagine something vast and ancient drifting in from the darkness beyond our familiar planets. And I often find myself wondering if you feel it too. Perhaps you can picture it now. A colossal world of ice, larger than any comet we have ever seen up close, slowly awakening after millions of years of silence. And that's the thing. This giant we call Bernardinelli Bernstein is not just a visitor, not just a wandering chunk of frozen dust, but also a sort of time capsule carrying whispers from the earliest days of our solar system. You know, and when I think about it, I can almost sense the cold stillness of that remote frontier, the place where sunlight fades into memory and gravity writes its stories in long, long, slow arcs. So let me ask you this, and take a moment with it. What does it mean when something that has slept since before humanity existed begins to return inch by inch toward the warm inner light? Why now, in this moment of ours in the year 2025, does this object rise from the deep like a memory trying to speak? I suppose it reminds us that the solar system is it's not a quiet neighborhood at all, but a dynamic stage shaped by invisible forces drifting across the Milky Way. And perhaps, as we follow this giant on its long fall inward, we are also following the faint trail of our own origins written in ice and starlight. Before we go on, I'd like to ask you to subscribe to the channel and leave a like. My aim here is simple: to help you drift off to sleep while exploring the wonders of science. And where are you on the map? Let me know where you are in the world and what time it is in the comments. It's always fascinating to see who's joining us from all around the world. So let's continue. When we first meet Bernardinelli Bernstein, there is this gentle sense of standing at the edge of something ancient, something that has been waiting far longer than any story we humans have told. And I suppose the best way to begin is to picture a faint speck of light in a vast survey image, nothing more than a soft blur among millions of other soft blurs. That tiny point was all anyone had at first. It was 2014, long before we in 2025 would start whispering about this giant. And the Dark Energy Survey had been quietly collecting snapshots of the night sky, each one like a frozen moment in a cosmic time lapse. The astronomers scrolling through those images did not expect to discover a world. They thought they were just cataloguing background objects, stars, galaxies, the usual tapestry. And yet, buried in that tapestry was something moving slowly, stubbornly, as if it had been set on its path ages ago. You see, it started almost like an afterthought, a dim pixel here, a dim pixel there, spread across multiple exposures. And, well, once the motions were compared, once the team realized that the object was shifting ever so slightly from night to night, the possibilities widened. At first, they thought it might simply be one of those distant trans-Neptunian objects, another frozen shard drifting around the outer edge of the solar system. But the more they looked, the more the numbers refused to behave normally. The calculated brightness was too high, the estimated size too large, and the distance much farther than the usual suspects. It wasn't just unusual, it was extraordinary. I suppose the remarkable thing is how modest the discovery looked at the start. You know, we often imagine great discoveries arriving with dramatic flashes or bold claims, but in reality, many of them arrive quietly, almost shyly. Bernardinelli Bernstein was like that. It hid behind faintness, behind the simple assumption that nothing huge should exist out there. Not just a comet, but also not quite a dwarf planet, not just a visitor, but also a record keeper from the beginning of the solar system, a hybrid of sorts, a transitional world. And the more astronomers traced its movement backward and forward in time, the more they realized that its orbit stretched unimaginably far, so far that it no longer felt like an object shaped by the planets, but something shaped by the galaxy itself. Um, Imagine a body roughly 85 miles across, about 137 kilometers of ancient ice and dust. Imagine that it dwarfs every familiar comet we have ever studied, that it outweighs interstellar visitors, like 3I Atlas by orders of magnitude, tens of thousands of times more massive. And, well, picture its surface, gently rounded by its own gravity, because this object is big enough for that, big enough to be sculpted into a near sphere, big enough to feel like a small world rather than a jumbled pile of rubble. When you let that idea settle, you begin to understand why so many astronomers felt a kind of reverence when they realized what they were looking at. That sense of reverence is difficult to ignore. It's not just an object. It's a chapter carved directly from the time when the planets were young, when everything was still swirling in the protoplanetary disk. And while ordinary comets are often thought of as messengers from that era, they are usually tiny, battered, reshaped by repeated journeys toward the Sunday. But Bernardinelli Bernstein is different. It has not been cooked or cracked by many passages. This is likely its first inward journey since the birth of civilization, maybe even its first in millions of years. It is pristine, almost untouched. So what we're seeing is not just an old world, but an old world preserved. And I find myself wondering, as I talk about it now, how much of our fascination is scientific and how much is emotional. We grow older, clocks tick, memories fade, and yet here is something that remembers for us, something that was pushed gently out into the cold, distant Oort Cloud before the Earth had even settled into its stable rhythm. That cloud, by the way, is a vast sphere of icy bodies so distant that the sun is little more than a bright star. And the objects there are mostly invisible to us, waiting in a kind of gravitational limbo. Many of them will never return, but some eventually drift inward. Bernardinelli Bernstein happens to be one of those rare wanderers. And the thought of that is almost poetic, almost like a forgotten letter finally finding its way back after epochs of quiet. You know, when you consider the sheer scale, the sheer improbability of encountering something this large, so far away, it becomes clear why this discovery was such a shock. It's not that scientists didn't believe such worlds could exist. It's that finding one is like finding a dragonfly wing in the middle of a desert and realizing the whole forest must be nearby. Bernardinelli Bernstein suggests that the Oort Cloud might be filled with worlds of this scale, not just debris, but also sizable bodies, maybe hundreds of them, maybe thousands. Whether it exists as a whole population, we still do not know. But the hint is there, the shadow of possibility is there. And as we study it more deeply, we notice that Bernardinelli Bernstein behaves like a comet in some ways. It releases gas, forms a coma, breathes softly into space as sunlight warms its ancient ices. Yet it also behaves like something larger. It rotates slowly, its gravity pulls itself toward a rounded shape, and its interior likely holds layers formed at different temperatures during the earliest stages of the solar system. Not just ice, but also organic compounds. Not just dust, but also trapped gases from the sun's infancy. It is, well, it is a museum of frozen epochs. So, so when astronomers finally realized what they were dealing with, the reaction was a mixture of disbelief and awe. The orbit they calculated showed that it came from tens of thousands of astronomical units away, a distance where interstellar space begins to whisper, and the near perpendicular tilt of its orbit revealed a history shaped not by the planets, but by the galactic tide, and perhaps even passing stars. This is why some have speculated that maybe it wasn't born here at all, maybe it was captured long ago, not just a child of the sun, but also possibly a child of another star. That idea remains only a possibility, but you can feel the excitement of it, the way it blurs the boundaries of what we think we know. As the team continued tracking it, they noticed its trajectory, bringing it slowly toward the region near Saturn, where it will reach its closest approach in the early 30s. That sounds close, but of course, in cosmic terms, it is still far. Far enough that it poses no danger, far enough that it remains a quiet traveler. And because of that distance, we are given a rare gift. We get to watch the slow awakening of a primordial world. We get to see how a giant comet breathes and sheds its skins as it approaches the Sunday. We get to witness the beginning of a journey that started before humans learned to write, before continents took their final shape. It's not an aggressive approach. It's more like a slow exhale, the kind that makes you think about how the solar system has always been alive with motion, always shaped by forces, subtle and patient. And as we observe Bernardinelli Bernstein with telescopes like Hubble and ALMA, we find more hints about its nature. We see its coma forming earlier than expected, driven not by water ice but by carbon monoxide, a gas that evaporates at temperatures far colder. That suggests a deep reservoir of volatile materials inside, preserved like pages of an ancient script. And page by page, as sunlight penetrates deeper, those secrets rise to the surface. You know, the more we examine these clues, the more Bernardinelli Bernstein feels like a bridge between two worlds. Not just a comet from the Oort Cloud, but also a window into the history of planet formation. Not just a wandering body, but also a messenger from a time when the sun was surrounded by a swirling disk of gas and dust. And the strange part is how something so old can feel so alive. How an object that has been drifting in darkness for millions of years can suddenly become a story we are all part of. And maybe that is why this discovery resonates. It reminds us that the solar system is larger than our daily experience. It's not just the planets and the moons we read about in school. It is a dynamic environment shaped by the galaxy, filled with dormant worlds waiting to wake. Bernardinelli Bernstein is simply the first one large enough for us to notice clearly. Well, as we follow its slow journey inward, we begin to wonder about the influences that pushed it from its distant cradle. Was it the tidal pull of the Milky Way, a passing star nudging it ever so slightly, or something more subtle, some random accumulation of small perturbations across eons? And those questions naturally lead us toward a deeper mystery, one that begins to unfold when we speak of the forces that disturb the Oort Cloud itself and awaken giants like this. Because the story of Bernardinelli Bernstein does not end here. It reaches outward into the realm where darkness, distance, and gravitational whispers shape the long fate of worlds. And as we move forward, perhaps it's time to look more closely at that distant cradle, that sphere, of icy bodies and explore what truly stirred this giant from its ancient sleep. Well, as we follow Bernardinelli Bernstein's slow descent toward the inner solar system, we can't help but ask, what exactly stirred it from its long sleep? You see, out there in the distant dark, far beyond the orbits of Neptune and Pluto, lies a region so vast and so quiet that time itself seems to move differently. It's called the Oort Cloud, and it stretches, well, perhaps 2,000 to 100,000 astronomical units from the Sunday. That's so far that the sun itself would look no brighter than the evening star does to us. And in that darkness, trillions of icy bodies drift, each one a frozen memory, each one a relic of the solar system's youth. Most of them will never come close to the light again. They remain suspended, like dust caught in a sunbeam that never fades. But sometimes, something changes. Sometimes a whisper of gravity reaches out, and one of those sleeping worlds begins to fall. That's what happened to Bernardinelli Bernstein. For billions of years, it had been resting there, orbiting so far away that its motion was barely distinguishable from stillness. Then, quietly, it began to move inward, its path bent by a force, subtle yet inexorable. And, well, that's where the mystery begins. Why now? Why this moment in cosmic history? After eons of drifting undisturbed, what nudge could possibly awaken such a giant? Astronomers, have thought deeply about this. They've proposed several possible causes, none of them mystical, all of them rooted in the slow dance of gravity. One of the leading ideas is something called the galactic tide. You might imagine, well, the Milky Way as an ocean of stars, gas, and dark matter, and our solar system as a tiny boat gently rocked by its currents. These tides, faint but persistent, can subtly distort the outer edges of the Oort cloud. Over millions of years, they can change the shape of orbits, just enough to send a few objects inward. It's not dramatic, not like a crash or a collision. It's more like a sigh, a slow rearrangement of invisible balances. And that small change, accumulated over vast spans of time, can turn a silent wanderer into a falling comet. Still, that might not be the whole story, because as the solar system moves through the galaxy, it doesn't travel through empty space. Every few 100 million years, it passes near other stars, sometimes close enough that their gravity brushes against the Oort cloud. And imagine that a star, perhaps a red dwarf, drifting past a few thousand astronomical units away, its gravity tugging ever so slightly at the frozen edge of our home system. Just a small pull, barely measurable, but across millions of years it could change everything. A single close encounter like that can fling thousands of icy bodies into new trajectories. Most will drift back into the deep, but one, maybe just one, will start its long fall toward the Sunday, and that one might be Bernardinelli Bernstein. So it's not that this event was destined. It's not that something decided now was the right time. It's chance, built from the mathematics of motion and the vast patience of the cosmos. Each time a star passes by, the dice are rolled again. And the Oort cloud, you see, is like a great cosmic reservoir, storing energy and possibility in equal measure. Every so often, one of its frozen members crosses the invisible line where gravity shifts its allegiance from the galaxy to the sun and begins its slow return. That idea of slow return fascinates me. It's like memory resurfacing after a lifetime of forgetfulness. And when you think about it, Bernardinelli Bernstein isn't the only one. There must be others, countless others, drifting inward from every direction. We just haven't seen them yet. Our telescopes are finally sensitive enough only now, in the early years of 2025, to notice such faint intruders. So maybe the real story is not that the Oort cloud has changed, but that we have. We are finally capable of seeing what was always there. But let's linger for a moment in that cloud itself. It's not really a cloud in the ordinary sense. It's not misty or glowing. It's an almost perfect vacuum sprinkled with ancient worlds. Some are the size of mountains, some the size of cities, some like Bernardinelli Bernstein, the size of small planets. The objects move slowly, following elliptical paths that can take millions of years to complete. And the boundaries are so diffuse that no one truly knows where the solar system ends and interstellar space begins. That uncertainty gives the Oort cloud its strange beauty. It's both ours and not ours, both parts of the sun's family and parts of the galaxy's wilderness. And perhaps that dual nature is what allowed the forces of the galaxy to awaken Bernardinelli Bernstein. The galactic tide pulls one way, the sun another, and between those two pulls lies a fragile equilibrium. Break it, even slightly, and an object begins to fall. But, and this is important, it's a fall that takes millions of years. When Bernardinelli Bernstein first started moving inward, dinosaurs still walked the Earth. It's only now, as we build space telescopes and probe the edge of the solar system, that it's nearing a place where we can actually see it. So in a way, it's as though the universe had been writing this story long before we were here to read it. Now, some scientists suggest an even subtler explanation, something called orbital diffusion. Over time, the gravitational tugs of passing stars, molecular clouds, and even the shifting distribution of dark matter can cause tiny changes in an object's orbit. Each change is minuscule, almost meaningless on its own, but they add up. They accumulate like ripples on water. And over billions of years, those ripples can push a world, like Bernardinelli Bernstein, gradually inward, without any single dramatic event. It's a story of time doing what time always does, transforming, shaping, eroding the stability of even the most distant realms. What's beautiful about that idea is that it replaces drama with patience. It tells us that the solar system isn't a static machine, but a living, breathing system that evolves on unimaginable timescales. The forces that guide Bernardinelli Bernstein are not sudden or violent. They are soft, continuous, like a whisper across eternity. And the more we think about it, the more we realize how delicate the balance is. A world that has slept for eons can awaken because of 1,000 tiny influences, none of which know they are working together. There's something humbling in that, because it reminds us that our place in the cosmos is not fixed either. The same tides that move comets also move stars, and the same galaxy that nudges Bernardinelli Bernstein closer to the sun also carries our planet along in its orbit around the Milky Way. We are, in a sense, passengers on the same current. And perhaps that's why we feel such connection when we watch a comet return from the dark. It's a reflection of our own motion, our own restlessness. Now, to understand why this moment matters, we can think of the Oort cloud as the boundary between order and chaos. Inside, the planets follow predictable paths. Outside, everything blurs. Gravity weakens, trajectories stretch, and even a passing whisper from a nearby star can alter the future. Bernardinelli Bernstein, then, is a messenger from that boundary, a record of what happens when order meets the wild edge of the galaxy. Its journey inward is not a warning, but a story, a reminder that the solar system is still part of a larger dance, one choreographed not just by the sun, but by the galaxy itself. And uh, when we step back and imagine this dance, it becomes easier to see how improbable, how miraculous our observations are. The fact that we can even detect this object, predict its orbit, and study its composition means that we are beginning to listen to the quiet conversations of the cosmos. Each comet, each drifting speck, tells a story written not in words, but in orbits. And Bernardinelli Bernstein's orbit says, "I have returned. I have been stirred by forces you can barely perceive." It's not, it's not that we are special for noticing it. It's that for the first time, we are aware of being participants. We see the slow machinery of the galaxy at work. We see how every object, from the smallest grain to the largest world, is part of a continuum of motion that never truly ends. And when you start to think about it that way, even gravity begins to feel poetic, a kind of memory that binds everything together, that connects the long past to the bright present. So here we are, watching this icy giant begin its return, tracing a path that began billions of years ago, a path sculpted by invisible tides. And as it moves closer, inch by inch, we can start to ask another question, one that looks beyond the cause of its awakening to the shape of its journey itself. Because the orbit Bernardinelli Bernstein follows is unlike any other. It cuts across the plane of the solar system, almost at right angles, like a visitor from another dimension. And that strange geometry might hold clues, not only to where it came from, but to what our solar system once was. Perhaps, as we turn to that question next, we'll begin to see that its path through space is also a path through time, and that the shape of its orbit is, in a sense, the fingerprints of everything that has ever touched it. Well, when we trace Bernardinelli Bernstein's orbit on the great map of the solar system, the first thing that strikes us is how wrong it looks. It doesn't flow neatly along the same flat plane where the planets dance. It doesn't belong to that thin, bright disk we call the ecliptic. Instead, it comes in almost from above, diving toward the sun at an angle so steep it's nearly vertical. You can picture it like a stone dropped from the ceiling of a spinning room, cutting across all the motion below. And that image alone tells a story written not in words, but in geometry, a story about a violent, ancient, and perhaps accidental past. The solar system, you see, is flat by nature. When it was born, billions of years ago, gas and dust spun together into a thin rotating disk. The planets grew from that disk, the asteroids formed inside it, and most comets follow orbits that still trace its outline. Everything, well, almost everything, moves in roughly the same direction, like boats following the same current. And then there's Bernardinelli Bernstein, whose path doesn't follow the current at all. It cuts across it. It breaks the rule. And that makes it fascinating. You know, it's not just the inclination of the orbit that's strange, it's what that inclination implies. Because if an object travels at nearly a right angle to the ecliptic, it suggests that something, sometime, must have twisted its motion. It means that gravity, gentle, invisible, but relentless, must have pulled it off course. The question is, whose gravity did that? Was it one of the giant planets? Or something much farther away? Something beyond Neptune, beyond even the edge of the sun's known domain? And as we look closer, the answer becomes even more uncertain. Bernardinelli Bernstein's orbital tilt over 90 degrees isn't the kind of thing a single close encounter can easily create. It's more like a scar from long cumulative chaos. It could have been sculpted by the collective gravity of passing stars or by the slow, deep pull of the Milky Way's tidal field. Or perhaps, and this is the more tantalizing idea, it might hint that there's more mass lurking out there than we currently know. Maybe uh, the orbit remembers something we've forgotten, a hidden planet, a distant brown dwarf, or a dark concentration of matter we've never seen. That that thought lingers, doesn't it? The idea that the solar system might still be incomplete. We've spent centuries mapping every visible world, yet here comes an orbit that doesn't fit. It's as if Bernardinelli Bernstein were pointing quietly but insistently towards something still hidden. And the more we study it, the more that possibility takes shape. Because when you map the paths of the most distant objects, we've discovered those frozen bodies at the edge of the sun's influence, you start to see patterns, alignments, subtle echoes of some unseen gravitational hand. Some astronomers call this the Planet 9 problem, others call it a coincidence. But either way, Bernardinelli Bernstein joins the conversation simply by existing. Um, uh, Imagine what its orbit looks like from above. The planets form a thin ring, all spinning in harmony, while Bernardinelli Bernstein's path dives through that ring like a sword through water. Each time it passes through, it crosses the invisible highways of Jupiter, Saturn, Uranus, and Neptune, though far above or below their actual paths. It's a kind of celestial choreography, silent but full of tension. Each crossing is a near miss, a reminder that the solar system isn't a sealed system at all, but a collection of constantly shifting relationships. And um, perhaps that's the real beauty of this orbit. It reminds us that space is not a static diagram, it's a living history of motion. Every tilt, every eccentric curve is the mark of something that once happened. Bernardinelli Bernstein's strange perpendicular path might have been written billions of years ago when the solar system was young and wild. Back then, the giant planets were migrating, moving outward and inward, scattering smaller bodies like seeds. The Oort Cloud itself may have been born from that migration. Worlds were flung outward by Jupiter's gravity, caught by the sun's pull, and parked in the farthest reaches. Bernardinelli Bernstein could be one of those exiles thrown high above the planetary plane, then left to drift for ages. And yet, well, some scientists think there's more to the story. They suggest that the Oort cloud might not contain only exiles. It might also hold strangers, objects that didn't form here at all. In the early days of star formation, the sun was part of a crowded stellar nursery. Dozens, maybe hundreds, of young stars were born from the same cloud of gas. Their planetary systems were close enough to brush against each other, to trade material like passing ships exchanging cargo. It's possible, even likely, that Bernardinelli Bernstein began around another star and the sun captured it later. Its strange orbit might be the fossil record of that ancient exchange. That idea makes me pause. Because if true, it means Bernardinelli Bernstein is not just a time capsule from our solar system's youth, it's an immigrant from another world entirely. It carries the chemistry, the dust, the frozen gases of a different star. It's not just telling us about where we come from, it's telling us who our neighbors were long before we ever had names for them. And that sense of shared origin, of cosmic mingling, somehow makes the universe feel smaller, more connected, more human. But whether it was born here or elsewhere, the tilt of its orbit still speaks of violence. At some point, gravity must have flung it upward and outward, tearing it from the orderly plane of the planets. It's not. It's not gentle, that process. It's like throwing a stone into a pond and watching the ripples distort everything. Except in this case, the ripples last for billions of years. And the more we study these tilted orbits, the more we see that the solar system's edges are not calm, they are turbulent, stirred by ancient encounters. And perhaps it's in those encounters that the story of Bernardinelli Bernstein truly begins. Because each time a massive planet like Jupiter or Saturn interacts with a smaller icy body, it can change its orbit dramatically, kick it outward, tilt it, even eject it completely. Over millions of such interactions, the solar system becomes sculpted. Some comets are lost to the interstellar void, some are captured again. Some, like Bernardinelli Bernstein, are thrown into orbits so vast and inclined that they spend nearly all of their time far from sunlight. What's remarkable is that after all this time, after all the pushes and pulls, it has returned. It's not just a wanderer, it's a survivor. And the angle of its orbit is like a record of everything it has endured. The fact that it still exists, still holds together, still circles the sun at all, tells us something about the resilience of matter, the endurance of gravity. Even at 90 degrees to the familiar plane, it remains part of the same family. We sometimes forget that gravity is not selective. It doesn't care about directions or definitions. It holds everything equally. The planets, the comets, the dust, they all fall together toward the Sunday. It's only our human need for order that makes us label one orbit normal and another strange. In truth, Bernardinelli Bernstein's path is as natural as any other. It's not wrong, it's just different. And that difference gives us a glimpse of how diverse the solar system's architecture truly is. Still, well, there's something uncanny about it. To see such a massive object approach from above, cutting through the solar system like a blade, feels almost cinematic. It makes us wonder how many others are out there following equally strange paths. If Bernardinelli Bernstein is one, could there be dozens more hidden, silent, waiting for their chance to be seen? And if their orbits share similar tilts, similar alignments, what might that say about the invisible forces shaping them? Perhaps we are only beginning to perceive a much larger pattern, one that connects distant comets, trans-Neptunian objects, and maybe even entire populations of unseen worlds. It's not about predicting doom or disaster. It's about understanding context. Bernardinelli Bernstein isn't coming to destroy, it's coming to teach. Its orbit is a clue, a fragment of a bigger picture. And that picture might include hints of how the solar system interacts with the Milky Way, how passing stars sculpt our boundaries, how chaos leaves fingerprints that we can still read billions of years later. You see, when we trace that steep arc across the ecliptic, we are really tracing history. The orbit is like a scar etched into space-time, showing where the solar system has been bruised, stretched, and reshaped. Every comet with a strange path adds another line to that invisible map. And Bernardinelli Bernstein, with its vast size and unusual tilt, may be one of the most important lines of all. And as it approaches its perihelion, its closest point to the sun, it will cut through regions of space we can observe more easily. Each observation we make, each image captured, will help us refine its orbit further. And perhaps, just perhaps, the precision of those measurements will reveal more than just numbers. It will reveal relationships. Because in the long run, orbits are not isolated. They talk to each other. They echo each other. The solar system is full of quiet harmonies that we've only just begun to hear. So, so maybe when we look at Bernardinelli Bernstein's path, we are really seeing the first notes of a larger cosmic melody, one that begins at the edge of the Oort Cloud and stretches all the way into the heart of the sun's domain. And as it continues its fall, we might begin to ask not only where it came from, but what lies beneath its surface, what secrets it carries inside that could tell us how such worlds are made and what they remember from the dawn of creation. Well, when we start to look not at the orbit of Bernardinelli Bernstein, but at the world itself, something changes. The story moves from geometry to matter, from motion to memory, because this object isn't just a traveler, it's a body, a physical thing, made of layers upon layers of ancient ice and dust. And those layers are, in a way, a frozen library of the solar system's earliest moments. When you look at it through a telescope, when you study its faint light through instruments like Hubble or ALMA, you're not just seeing a distant comet, you're reading a record written in the first language of the cosmos, chemistry. You see, the Hubble Space Telescope captured Bernardinelli Bernstein as a nearly spherical shadow, which is surprising for something that large and distant. Most comets we know are irregular, more like mountains tumbling through space. But this one seems round, shaped by its own gravity. That means it's massive enough for gravity to smooth its form, pulling the rugged edges into balance. It's not just a piece of debris, it's something closer to a world in miniature. And when ALMA, the great radio observatory in Chile, turned its ears toward it, it detected faint signals of carbon monoxide gas streaming away from its surface. That was the moment, I think, when scientists realized this comet was alive in its own quiet way. The presence of carbon monoxide, CO, a simple yet fragile molecule at such an immense distance, tells us something profound. At the edge of the solar system, where sunlight is weak and cold dominates, water ice remains solid and silent. It doesn't sublimate, doesn't turn to vapor. But carbon monoxide, well, it does. Even at temperatures hundreds of degrees below freezing, CO can escape, creating soft jets of gas that breathe life into a comet. And those jets, faint as they are, were visible to us even when Bernardinelli Bernstein was still billions of kilometers away. That's extraordinary. It means the comet contains vast reservoirs of these volatile ices, substances, so easily lost to heat that they must have been trapped there since the very beginning of the solar system. So what does that tell us? It tells us that Bernardinelli Bernstein hasn't changed much since its birth. It's pristine, almost untouched. It's like finding a fossil so perfect that even the cellular structure remains intact. And perhaps even more than that, it's like holding in your hand a piece of the nebula that once surrounded the newborn Sunday. The gases frozen inside it, carbon monoxide, carbon dioxide, methane, maybe even nitrogen, were once drifting freely in that ancient disk of gas and dust. As planets began to form, as gravity gathered the material into clumps, some of it was thrown outward, far into the cold, where sunlight could no longer reach, and there it stayed. For billions of years, it waited until now, until 2025, when we began to notice it again. When you think about it, that's what makes Bernardinelli Bernstein so special. It's not just its size, or its orbit, or even its brightness. It's that it remembers. It remembers a time before the Earth had oceans, before Jupiter was finished forming, before the solar system had even cleared its own debris. It's a messenger from the epoch when everything was still being decided. And each layer of its interior tells a different part of that story. The outer crust, well, that's where the dust collects tiny grains of silicate, fragments of rock that have been baked and refrozen countless times beneath. That lies a thicker layer of ice mixed with organic compounds, darker and more fragile. Below that, water ice, frozen carbon dioxide, and deeper still, pockets of carbon monoxide, maybe even traces of methane or ammonia. The deeper you go, the more pristine it becomes, the closer you get to the unspoiled chemistry of the solar system's dawn. And that's what scientists dream of studying. Because if we could somehow touch those inner layers, if we could drill through the outer shell and taste the gases within, we'd be touching time itself. But we can't, at least not yet. The comet is too far, too massive, its orbit too steep. So we study from afar, using light as our probe. Hubble gives us the shape, ALMA gives us the breadth, and between them we can begin to imagine what's happening beneath the surface. And that's where the story becomes almost poetic. You see, as Bernardinelli Bernstein approaches the sun, even at great distances, it begins to wake up. Heat seeps into the crust, reaching those pockets of volatile gas buried within. The pressure rises, slowly, invisibly, and then, somewhere on its surface, a crack forms. A narrow vent opens. Gas rushes out, carrying dust with it. That gas creates a faint coma, a halo, that glows as sunlight reflects off the particles. The comet begins to shimmer. It breathes. It's like watching a frozen world exhale after millions of years of silence. And, each exhalation carries away not just gas and dust, but information, the chemical fingerprints of its past. These jets of gas can sculpt the surface over time, carving grooves, exposing deeper layers. In some cases, the jets erupt with enough force to break fragments away entirely, reshaping the body bit by bit. And that possibility makes scientists wonder whether Bernardinelli Bernstein could one day split or fracture, as other comets have done. For now, it remains intact, but the physics is clear. As it warms, pressure builds, the deeper gases expand, and if one pocket bursts while another remains sealed, the imbalance could tear at the structure. And yet, that danger is also a gift, because those cracks and vents allow us to peer beneath the surface, metaphorically speaking. When we analyze the composition of the gases escaping, we can reconstruct what lies inside. We can measure the ratio of carbon to nitrogen, the isotopes of oxygen, the complex organic compounds that form as sunlight reacts with ices. And each of those measurements is a clue, a tiny revelation about the conditions under which this object formed. It's not random, you see. Every molecule has a story. The ratio of hydrogen to deuterium in water ice, for instance, can tell us how warm or cold the solar system was when the comet formed. The presence of carbon monoxide versus methane can reveal whether it condensed closer to the sun or farther away. And when we compare Bernardinelli, Bernstein's composition to that of smaller comets, we begin to notice differences that speak of scale and age, of how temperature and pressure sculpted the early solar system into layers of complexity. Perhaps the most remarkable thing is that Bernardinelli Bernstein behaves both like a comet and like a planetesimal. It's large enough to have gravity, structure, and internal layering, yet still volatile enough to outgas as it nears the sunday. It exists in that liminal space between categories, too big to be ordinary, too active to be still. And that duality makes it something rare, a transitional world, one that blurs the line between comets and dwarf planets? Well, you might think of it like this. If the planets are the symphonies of the solar system, grand, enduring, carefully composed, then comets like Bernardinelli Bernstein are the echoes that linger after the music fades. They carry the same notes, the same themes, but unrefined, raw, untouched. To study them is to hear how the melody began. And there's another detail that's easy to miss but deeply significant. The fact that Bernardinelli Bernstein releases carbon monoxide at such a great distance means it likely formed in one of the coldest regions of the early disk, perhaps beyond Neptune's birthplace, in the shadowed outskirts where the sun's warmth never truly reached. That means the molecules we detect today were trapped there 4.5 billion years ago, unchanged. The comet, in that sense, is a container of ancient sunlight, of chemistry older than Earth itself. So as it drifts inward, slowly brightening, we're watching not just a celestial event, but a kind of unveiling. Each step closer to the sun peels back another layer of time. And that peeling, that gentle erosion, allows us to glimpse what we could never otherwise see, the solar system as it once was, before life, before oceans, before certainty. Sometimes when I think about it, I imagine Bernardinelli Bernstein not as a rock or an ice ball, but as a memory with mass, a story drifting through the dark, waiting to be heard. It carries within it the whispers of the nebula, the frozen breath of long-dead stars, the chemistry of beginnings, and as the sun warms it, those whispers turn to song. The jets, the glow, the tail, they are not random phenomena. They are the comet speaking in the only language it knows. And perhaps that's why we find it so mesmerizing. Because in a way, we recognize ourselves in it. We, too, are made of the same elements, the same carbon, the same oxygen, the same ancient dust that once drifted through that primordial cloud. Bernardinelli Bernstein is not foreign, it's family. And its slow awakening reminds us that everything cold and distant can someday burn bright again. So the question becomes, what else is out there like it? How many other giants still sleep in the outer dark, holding secrets of the solar system's birth? Are we seeing one exceptional traveler, or merely the first of many? And as new telescopes search deeper into the sky, as we find more of these frozen giants, perhaps we'll begin to see patterns that link them together, patterns that hint at hidden forces still shaping the farthest edges of our world. And maybe, that's where the story must go next. Because Bernardinelli Bernstein doesn't drift alone. It moves through a frontier filled with other strange visitors, other wanderers with odd orbits, mysterious origins, and stories just as ancient. And together, they might reveal that the outer solar system is not silent at all, but alive with movement, waiting for us to listen more closely. Well, when we step back from Bernardinelli Bernstein and look toward the wider dark, we begin to notice something unsettling. It's not alone. The outer solar system seems to be waking up piece by piece, as if the edge of our world is breathing again after a long silence. And perhaps you've felt that too, the sense that lately more and more strange visitors have appeared in our skies. Oumuamua, Two-Eye Borisov, Three-Eye Atlas, and now this enormous ice giant from the Oort Cloud. It's as if the cosmos has decided to send reminders, one after another, that our solar system is not a closed room, but a crossroads. That realization changes the way we see things. For most of our history, we thought of comets as periodic guests, predictable, repeating, faithful to the Sunday. But these new arrivals, they come from directions we can't anticipate, on paths that seem to defy the old patterns. And when Bernardinelli Bernstein appeared, Many scientists began to wonder if there's more happening in the deep dark than we've understood. You know, um, it's tempting to see patterns where there are none. Human minds are wired that way. But this cluster of discoveries over just a few short years feels different. It's not just coincidence. It's not just improved technology. It's a whisper from the outer frontier. Of course, some astronomers remind us, well, that part of this mystery might be our own doing. Our telescopes have grown sharper, our sky surveys broader. We see more now because we're looking more carefully. The Dark Energy Survey, the Pan-STARRS system, the upcoming Vera Rubin Observatory, all of them scan the heavens with relentless patience. So, so naturally, we find things that would have gone unnoticed a generation ago. It's a reasonable explanation. The more you look, the more you find. But even so, even with that in mind, the number of massive, unusual, high inclination bodies appearing in such a short window of time, it makes you pause. And maybe it's not just us seeing better. Maybe something really is stirring out there. The edge of the solar system, far beyond Neptune, is a place of quiet chaos, a realm influenced not only by the sun, but by the galaxy itself. If the galactic tide can shift the orbits of distant comets, if passing stars can pluck them from their sleep, then maybe we're living in one of those epochs when many are set loose at once. A gravitational season of sorts. You see, cosmic processes move slowly, but they often come in waves. It's possible, just possible, that we're witnessing the crest of one such wave right now. Oumuamua, that slender, tumbling shard, was the first interstellar visitor ever recorded. 2I Borisov followed soon after, glowing faintly with cyan gas, its chemistry unlike any comet born here. Then 3I Atlas, another fragment of that same mystery, passing through like a shadow. And finally, Bernardinelli Bernstein, not interstellar this time, but enormous, ancient, and native to our own Oort Cloud. So maybe this is a pattern after all, not a random burst of sightings, but the first hints of how active, how restless the outer regions of the sun's influence truly are. And yet, it's equally fascinating to think that each of these visitors might be telling us about different forces at play. Oumuamua and Borisov came from outside, their trajectories shaped by other suns. Bernardinelli Bernstein rose from within, pulled inward by the faint hand of galactic gravity. Each one is a messenger from a different layer of the universe. Each one says, in its own quiet way, that borders are illusions. Space doesn't end where we stop looking. The deeper we search, the stranger the edges become. Take the objects we call trans-Neptunian, those icy worlds that orbit far beyond Pluto. Their paths aren't random. Many seem clustered, tilted, or aligned in ways that shouldn't happen naturally if only the known planets were influencing them. And that's why some astronomers have proposed a bold idea. Perhaps something massive is hiding in the dark, a distant planet, maybe 5 or 10 times the mass of Earth, circling the sun at a distance so great that sunlight there would be no brighter than moonlight here. They call it Planet 9. That idea captures the imagination because it offers a simple explanation. If there's a hidden planet far away, its gravity could sculpt the strange orbits we see, stretching them, tilting them, even gathering them into clusters. It could, in theory, be the conductor of this distant orchestra, keeping rhythm in the darkness. And it could also explain why objects like Bernardinelli Bernstein follow such eccentric paths, entering the inner solar system at odd angles. But not everyone agrees. Some argue that what we see might just be statistical bias, that we're looking in certain directions more often than others, and so our discoveries naturally form patterns. The data, they say, might not yet be strong enough to justify a hidden planet. So it's a debate, a beautiful one, between imagination and caution, between the desire to see meaning in the chaos and the discipline to question it. And that tension, well, that's what keeps science alive. Still, it's hard not to feel that something is guiding these outer wanderers. Even if Planet 9 doesn't exist, there are other possibilities, forces we've yet to fully grasp. Some simulations suggest that a faint density of dark matter around the solar system could slightly perturb long-period orbits, much like tides shape the ocean's surface. Others propose that we might be passing through a denser region of interstellar dust or gas within the Milky Way, creating gentle gravitational waves that ripple across the Oort Cloud. These effects are small, so small that we can barely measure them, but over millions of years, they might be enough to send a few giants inward. It's humbling, isn't it? The realization that Bernardinelli Bernstein's arrival might not be the act of a single cause, but the cumulative whisper of many of the stars, the galaxy, the unseen matter that makes up most of the universe. It's not a single story, but a symphony of subtle influences, all converging in one frozen traveler that just happened to be noticed by human eyes. And when we think of it that way, we begin to see the Oort Cloud not as a quiet storage room, but as an active, ever-changing frontier. It's where the solar system meets the galaxy, where local gravity and cosmic tides blend together. It's the place where stories like this begin. And if Bernardinelli Bernstein is one chapter, then the others, those smaller, faster, stranger comets, are the footnotes that make the tale complete. We tend to think of these discoveries as isolated events, but the truth is, they're part of a much larger pattern. Our solar system has been shaped, stirred, and occasionally disturbed by the broader motions of the Milky Way for billions of years. Every so often, something nudges the balance, and a few icy worlds begin their long descent inward. It's happened before, it will happen again. The only difference now is that we're here to witness it, to map it, to measure it, to ask what it means. Perhaps. Perhaps that's the greatest gift of Bernardinelli Bernstein and its kin. They remind us that the universe is not static. It evolves, it breathes, it interacts with itself in ways we're only beginning to understand. And they remind us too that discovery is not just about seeing new things, it's about realizing how little we've seen. Each new object expands the map, not just outward, but inward into our understanding. You know, it's funny, each time we detect one of these distant bodies, we give it a name, a label, a number, as though that makes it ours. But in truth, these worlds don't belong to us. They existed long before we looked their way. They move according to laws older than life. And yet, by naming them, by studying them, we join their story. We become part of the same cosmic process. They embody the act of motion, of curiosity, of persistence. And that brings us to something deeper. If the outer solar system is alive with hidden giants, if the Oort Cloud is whispering again, then Bernardinelli Bernstein might not be an exception, but a sign that our instruments have finally become sensitive enough to sense the pulse of the frontier. Maybe we are entering a new age of discovery, one where the boundaries between planets, comets, and interstellar wanderers begin to blur. So where does that leave us? In 2025, we stand at a threshold. The telescopes scanning the night sky are about to open their eyes wider than ever before. The Vera Rubin Observatory will soon begin its legacy survey of space and time, photographing the whole visible sky every few nights. It will see things faint beyond imagination, objects smaller, darker, farther than Bernardinelli Bernstein. And among them, perhaps, will be others like it. Maybe even the elusive Planet 9 itself. In It's thrilling to think that within our lifetimes, we might finally begin to understand the architecture of the farthest regions of our solar system. But it's also sobering because these discoveries remind us not only of how vast the universe is, but of how small our reach remains. Every time we see a distant world drift closer, we are reminded of all the others we cannot yet touch. And maybe, well, that's the next question we have to face. How far can we really go? How much of this grand celestial story can we hope to explore firsthand before the darkness closes again? Bernardinelli Bernstein may be a messenger, but it's also a mirror showing us the limits of what we can do from this tiny world. And as it moves inward, ever so slowly, it invites us to look not only outward to the stars, but inward to our own hunger, to know our own boundaries and the fragile reach of our science. So perhaps that's where we must go next. Because while Bernardinelli Bernstein offers us a glimpse into the past, it also poses a question about the future, about what it means for a species so small to study something so vast, about how we choose what to pursue, what to let go, and what to simply watch as it passes us by. Well, standing here at the quiet edge of everything we have traced so far, it feels as though 3I Atlas has already drifted into myth. Not myth in the sense of fantasy, but myth in the sense of something that lingers in the mind long after the object itself has vanished from sight. And, well, maybe that is the most fitting way to begin closing this long, wandering journey. Not with an answer, not with a solution, but with a recognition that the universe, in its vast indifference, sometimes gives us stories disguised as data. And it is up to us to decide what those stories mean. You see, after everything we have explored, the orbit, the anomalies, the surface, the ancient scars, the long escape into the dark, the truth remains beautifully unchanged. 3I Atlas did not come for us. It did not arrive with purpose, nor leave with sentiment. It simply passed by. A visitor moving on currents older than our species, shaped by collisions we never witnessed, carrying traces of environments we have never touched. And perhaps that indifference is what makes the encounter so strangely emotional. Because we want meaning, we want intention, we want the universe to look back at us, even if just for a moment. But objects like 3I Atlas teach us something gentler, something quieter, that the universe does not need to notice us for us to find wonder in it. It's not looking down at us, it's inviting us to look up. When scientists in 2025 pieced together the last fragments of its light curve, the last whisper of its trajectory, they spoke with a kind of scientific humility that is rare in an us-abound age so hungry for certainty. They said, simply, that much of the evidence supports a natural origin. They said that the anomalies, though puzzling, fall within the vast domain of what nature might produce across billions of years. And they said something else, something that feels in a way like the emotional center of this entire path we've walked together. That mysteries like this are valuable precisely because they resist closure. So what do we do with that? What do we do with a visitor that leaves behind more questions than answers? Well, maybe the right response is gratitude. Gratitude that in a galaxy so large, an object so ancient wandered close enough for us to notice. Gratitude that the encounter stretched our instruments, our theories, our imagination. Gratitude that even if we could not decode every piece of its nature, we were given the chance to try. And, well, perhaps the deeper meaning lies beneath that gratitude, a reminder that science is not a catalogue of certainties, but a conversation between what we observe and what we long to understand, between the world as it is and the world as we imagine it could be. 3I Atlas, in its brief flicker across our telescopes, became part of that conversation. It asked us to reflect, to reconsider, to admit what we do not know. It also asked us to be humble, not just in the face of the unknown, but in the face of the unknowable, because some features of its history may be permanently erased, some chemical signatures too deeply altered, some origins too thoroughly hidden by time's patient hand. And that is a kind of beauty in itself, a beauty rooted not in revelation, but in restraint. We grow older, clocks tick, and we come to realize that the universe owes us no explanations. Yet it grants us glimpses, short, delicate, fleeting, and in those glimpses, we find ourselves expanding, stretching our minds towards scales that dwarf us, and yet somehow make us feel more connected, not less. Think of the 8 anomalies we traced earlier, each one a doorway into deeper questions, each one a reminder that nature is not tidy, that nature does not conform to the patterns we prefer. And whether it was the nickel without iron, the deep negative polarization, the faint anti-tail, the puzzling acceleration, well, whether it exists at all as a unified story is uncertain. But the combination forced us to step outside familiar frameworks, forced us to imagine possibilities we had not considered, forced us to accept that science grows most when faced with discomfort. And there is something quietly inspiring in that. It means that even within the small span of human life, even within our limited ability to sample the galaxy, the universe can still present us with an object so strange that we must pause, we must breathe, we must rethink. So perhaps the legacy of 3I Atlas is not its composition, nor its orbit, nor its destination, but the way it loosened our grip on certainty, the way it invited humility, the way it whispered that our models must always remain open, always remain willing to evolve. And while most lines of evidence lean toward a natural origin, the true significance lies not in confirming the ordinary, but in expanding our sense of what the ordinary can include. Natural does not mean simple. Natural does not mean familiar. Natural does not mean predictable. Nature, across cosmic time, is as creative as any storyteller. In that sense, this interstellar traveler becomes a teacher, not just teaching us about chemistry or dynamics or cosmic ray processing, but teaching us about our own limits, teaching us about patience, teaching us about wonder. And when we place its journey against the backdrop of human curiosity, something tender emerges, a kind of shared trajectory. It heads outward, further into the dark, and we, in our small way, head outward, too, through telescopes, through missions, through imagination, not just outward into space, but also inward, into the part of ourselves that longs for connection with the cosmos. It's not out there, it's in here, this desire to understand. And that, perhaps, is the deepest link between us and an object that has never known we exist. Now, as the object fades, as the faint trace of its light dissolves into background dust, we are left with the pieces, the fragments, the unanswered questions. And these become the building blocks of future science, future missions, future generations, who will look back and see 3I Atlas as one of the early members of a new field, the study of interstellar visitors. And this is where the forward momentum returns, because even though this visitor has left, others will come, and we will be ready, more ready than before, better instruments, faster missions, more imaginative models. And perhaps someday a probe that will meet one of these travelers in the quiet interstellar dark. It, it is worth remembering that this is only the beginning. In the span of cosmic time, 2017 to 2024, the era of Oumuamua, Borisov, Atlas is just the first whisper of a field that will grow into something extraordinary. A field where humanity no longer watches interstellar objects from afar, but intercepts them, studies them, maybe even captures fragments of them. And from those fragments, new sciences will grow. So, so as we draw this long reflection toward its final breath, it becomes clear that three Atlas did not just pass through the solar system. It passed through our understanding. It passed through our imagination. And like any good teacher, it left before we were ready for it to go. But the story is not over, not just yet, because now, having walked through its orbit, its anomalies, its surface, its journey, and its meaning for humanity's future, we find ourselves at the threshold of something even deeper, a question not about the object, but about us. What do encounters like this reveal about the human mind, about our longing, about our capacity for awe? And that is where the next chapter gently begins to take shape, a chapter where the universe becomes a mirror, where cosmic visitors reflect something essential about who we are, and where humility becomes not an end, but a beginning.